In the previous video, we talked about reflection lighting for the exterior and the important parts where reflection is needed. Now it's time to move on to interior lighting. Our interior lighting definitely won't be something like this because it's neither correct nor principled. It's very uniform and boring, and if we were to walk through this environment, it wouldn't offer anything attractive. To make it more appealing, we need to create a light mood for ourselves. How can we create a light mood? One of the simplest ways available now is using artificial intelligence. You can use different AIs to build your light moods for various conditions. First, let me explain what kind of idea this light mood gives you. For example, you might want to instill a sense of fear in your environment, or the feeling of a dark atmosphere where something unfortunate has happened, or even a sense of happiness and joy. Look, light is a very important subject. With light, you can transform a static space into all sorts of different environments with different moods, and a light mood specifically helps you achieve this. Now, we want to proceed here using a very simple method, which is utilizing AI. Previously, it was such that you had to go and gather lots of references from movies, series, animations, and games and put them together. You'd try to bring out a certain feeling in your scene using those references and run various tests until you reached a result. Here, we can replace that searching stage with AI. That is, we can take a series of images or screenshots from our own scene, give them to the AI, and ask it to light them and create a new light mood for us based on the feeling we want. For instance, fear, greed, a dark environment, or creating a sense of curiosity for the audience as they walk through the scene. To take a screenshot, what we can do is click on the 3 lines at the top and use the high-resolution screenshot option. We click on this option and a window appears. When we click Capture, and then click on the address that appears at the bottom, it brings up the screenshot for us. I'll take screenshots from several different places, for example, from these stairs, looking down. I've taken various screenshots that I can use. Now we go back to the AI. Which AI can we use? You can use any AI model that you know or like. There are no limitations. However, here I want to use the most accessible AI possible. ChatGPT. In ChatGPT, the first thing I do is write to it asking it to create 4 light moods for me for an interior space where I want the colors to be, for example, orange and white. It then provides me with several different light moods that I can use in a general sense. I can say, okay, now I'll put orange light on the walls and columns and work with white light on the ceiling. And in this way, I can create a light mood like this. Another method is to give your own images to the ChatGPT AI and tell it that you want to have a light mood like this, asking it to do this for you. Let's do this together. Of course, it has daily limitations. You can wait for that limit to pass or use other AIs in the same way. First, I'll load my image here and write the prompt. What we did was provide the image and ask it to generate a light mood for us based on the photo provided. I specified that I want the atmosphere to be dark with orange and white lights, and I want a scary feeling in the scene, asking it to create 2 versions. It created the first one, which is an image like this. It's a very good image. I can take ideas from it and start my work. I just told it that the light I have outside the scene coming in is blue, and it generated this other image for me. Now I take these images and make a plan for myself. I say, okay, I'll turn off all the lights, and I'll start by placing the lights that I know must exist. Once we've placed the primary lights, we'll start placing the secondary lights. So we now roughly understand how to have our own light mood. I can even tell it that I want my environment to be darker and to use green light instead of orange, which creates different variations for me. For example, this could be a very interesting lighting mode for my scene. I'll start copying all of these and placing them in the PureRef software. When I do this, I'm essentially creating my light mood board. Now I have different lighting conditions with various themes, and I can start testing them on my scene. Now, how do we start testing in the scene? This is a very important option. You see, in the scene, you have places where you know light exists. Like what? Like the places where you've placed these lamps. Or, for instance, your window, where light clearly enters from outside, correct? Okay, so in the places where I have light, I must first place lights and then adjust them. After that, I can start adding secondary lights, or lights that are meant to bring this mood back into my scene. I'll start doing this, but with a difference. I want to tell you a point regarding blueprints, how we can create prefabs and use them. Okay, so now we understand the light mood issue. What light mood do I want to choose for this scene? Something like this seems attractive to me. We place some lights at the base of our columns with a color that can be orange or red, it doesn't matter. And in the ceiling and for our main lights, it will be white light, okay? So the main light is white, and the lights next to the columns are orange. After I explain to you how to build prefabs, we'll move on to creating this light mood and proceed with our work. Well, let's explain and see what a prefab is. Look, I've decided that wherever this light source is, this lamp model, there should be a light in front of it. A light that could be a rectangle light, a point light, or a spotlight, depending on the shape we have in our light source. Normally, we consider it like this. We come here, click Create, and for example, draw a rectangle light, bring it here, and place it. We press the G key so we can see the light shape and adjust its position. We might say our light should rotate like this, 45 degrees, and be placed here. We adjust its radius and set the angle using the barn door angle. Well, we conclude that this light we've placed is okay now. It's a good light and we want to use it. But we have a few problems. First, if I want to repeat this light throughout the scene, there are a few ways for us. One is to group these two models together, meaning come here, right-click, or use Ctrl-G on the keyboard to group them. Now I can repeat this group, copy it, and place it in different spots. But a major problem that arises is that my actor count doubles as I go forward. That is, if I have 10 lights, I suddenly have 20 actors that I have to manage together. If I'm moving the light's position, I also have to move the light model and handle things like that. Well, generally speaking, if I were to tell you, this method is a lot of trouble, and we can fix these issues using a very simple technique through blueprints. For those of you making game assets, when you have complex objects made of smaller sub-objects you created earlier, you can very easily build prefabs, and then even put that prefab up for sale as part of your content. Or if you're preparing a scene for your portfolio, you can later present these prefabs separately in your artwork and write separate explanations for them, showing that you have the skill to analyze problems, find them, and solve them. Okay, now how do we build a prefab? First of all, let me ungroup this. We come here and ungroup it. Building a prefab is very simple. We go to our content browser, go into our folder, right-click, and create a new folder. We name it Blueprint, and in the Blueprint folder, we create a Blueprint class. Here, we must select the Actor option, because as I told you, we want to create a new actor. When we select Actor, I'll name it Light Actor. Up to this point, for static meshes, we used SM at the beginning, for textures, we used T, and for materials, we used M. What should we put for blueprints? For blueprints, we use BP underscore, meaning the naming of blueprints should be in this form, BP underscore followed by its name. Well, this is my light actor. I double-click on it, and a new page opens for me called the Blueprint Editor. In this editor, where we have work now, is the viewport section, and the simplest way to use a blueprint is to create a prefab. Well, what is supposed to happen? Essentially, I'm considering a new space for myself called a blueprint. Now I arrange a series of objects together. I arrange items like light, or we can add sound, and different elements together and use them as a single actor in our level. It's like being grouped, but much more orderly, organized, and you have a separate space for editing. Let's go further, and I'll tell you its advantages too. We said we want to do what? We said we have a model. What is our model? The SM/lamp model. I grab this, drag it here, and drop it. This part is added for me. I keep it right where it is, meaning I don't change its position. Now this becomes my prefab. But as I said, besides the lamp itself, we want to consider a light for it too. I come here, click the Add button, search for light, and select the rectangle light option here. I rotate this light 90 degrees so it's placed exactly downwards in this section. We can go to the top view, zoom in a bit, and have the settings we need here. For example, I'll decrease its size a bit here and increase it on the other side so the light simulation happens like this. After we've placed our light and performed our initial desired settings, it's time to go into the scene, and let me tell you some of the advantages of this blueprint actor and where it's used. I go to the blueprint folder and see that an actor has been added. If I click and drag, I now have my light with the lamp model. Do you know what the first advantage of a blueprint actor is? Let's consider a scenario where we have a light and a lamp model that are repeated 100 times in our scene. We've learned two methods so far. Either group these two and repeat them 100 times, or use a blueprint actor. Which method is more logical? 100% the blueprint actor. Why? For two reasons. 1. Loading and processing it is much simpler for the engine. 2. You can have better and faster access to the settings of the model and the light within that blueprint. Let's test this together. I'll make 3 copies of this. I go into the blueprint actor and say I want all my blueprints to turn red. I selected one light in the blueprint actor, changed its color to red, saved it, went back to the scene, and all the blueprint actors turned red. But normally, if I wanted to copy these, I'd have to go and select the lights one by one and then change their light here. And this selection process is something that normally could take a lot of time. If you wanted to select 100 lights from your outliner and then change them, then maybe revert some of them, it's a whole ordeal. But in the blueprint actor state, you've turned these 3 red and say, I want to bring this middle one a bit further this way, and I want its light color to be blue. You select the blueprint actor once, go to the details section, select the light, and set the color to whatever you want. The settings related to the model and the light are all right here in a very detailed panel for you to change. Now, where is the interesting part? We want to decrease the overall influence of this light. I come here and decrease its radius. For example, I set it to 183, save it, and go back. The influence intensity of all the lights has decreased. Again, I say, this one I separated and brought over here while I don't want this to happen to it. And I want its influence intensity to be more, and it's very easily accessible for me to do that. So prefabs are a very important and vital option for us. Now, what I'll do for my scene lighting is create 2 prefabs. The first prefab is for this light we have here that we just built together. The second prefab is for the light we want on these columns. Let's build this one together too to review the creation process. Then we'll move on to the lighting process. My lighting is also very simple. Overall, I want to have a white light in the places where I have lamps and implement that same lighting I told you about on these columns. What we do is come here and create a new blueprint. A blueprint actor named BP_column actor. I open it and go into the 3D space. In this 3D space, what we do is bring our column model here and add it like this. Once it's added here, I want to do a few things. First, I want to place a lamp model here and then consider a light for it, exactly like the prefab I built. The process of adding light is a state where we must see the effect in the scene, because unlike those ceiling lights where the model and the light placement are clear, this column model interacts with its surrounding environment. Now, let's see how we can do this together. The first move is to come to my level, select all my point lights, and hit the delete button. Essentially, I've practically turned off all my lights because the lighting is going to be done from scratch anyway. I'm also completely removing these lights. Just pay attention to the lights. Now what I do is bring my column, the column blueprint actor, here and place it. I rotate it 90 degrees like this. Now anything we work on this blueprint in this window will be added in real time. To see the effects directly, we come to this section and place our blueprint window here on the side. Initially, what I want to do is come to the side of the work and add a light. Let's do this together. I hit Add, Rectangle Light, and name it Side Light _01. After doing that, we go to the Light section and set its units to candelas like this and assign it to this column. Now I'll change its position. First, I'll set its size to 10 by 10 because I want it to be very small. For this part of the decal that has a glowing point, I want to consider a light source for it. We specify the position exactly where we want it to be, and now we move on to, for example, adjusting the barn door angle for this light we've placed. I'll set it to, say, 35 and bring it out a bit like this so it takes its place here. I'll also decrease its intensity a bit. I'll bring its influence intensity quite a lot, meaning we'll consider it at about 250 because we want its intensity to be only within its own range, and I think we've changed almost everything needed here. I can also bring this barn door length down a bit. For example, set it to 10 like this. And now we'll take a duplicate of it and bring it to this side and add it because we want to have it on both sides. Now I select both lights and consider an orange color for them. Okay, the lights next to my column have been created. Now I also want to have a light for this middle and front part. To do this, I'll again consider a rectangle light and name it Front Light, and I'll again assign it to my column. Let's go through the settings. First of all, I'll set its units to candelas, then set it to 2 because I don't want its intensity to be very high for now, and after that I'll bring it forward and place it here and rotate it 180 degrees. After that, we move to its radius of influence, which we'll set at a value like, say, 250 again. It could be less, for example, at a value like 115 or 120, because I don't want it to be very scattered and large. After that, we move to its size. We can take the size as, say, 25 by 10, so it has that stretched state. I'll set the barn door length to 10 like before, and set its angle to something like 45. I'll bring it up a bit so it has exactly the desired position, and all the light I wanted has been placed here for me. Now I can increase this radius a bit more. For example, set it to 300, so a larger radius is influenced here. Later, these are all editable. We can edit them. Well, that's for our column. Now we want to go after adding a lamp model and the light in front of it. We can use the previous blueprint we built, the light actor, but here, to avoid technical issues bothering us, we'll do it from scratch because it's a very simple task. We come here, select the static mesh for the light, add it here, bring it to the place we want, and set it. In this state, we'll bring it up a bit like this. Now it's time for us to consider a light for this part too. So I'll consider a rectangle light for it here. The first thing I do is set its units to candelas. The value can be 8. We can even take it lower. Let's set it to 6 for now. I'll bring the influence intensity, or that radius, down a bit to about 500. Then we specify its place, bring it up, rotate it 180 degrees, and now we move on to its shape and appearance. I'll set a value like, say, 15 and 90 to bring out this rectangular form for us. I'll adjust the angle to a value like 45 and set the length to 10 like before. I want to shift the color of this light towards blue because just as it was in my light mood, I can combine blue light with orange or red. Okay, I'll hit OK here. I'll bring the light a bit closer to the lamp itself so it looks like it came from this same light source. I'll make this bottom light the exact same blue color too. Okay, now we can see the combination of these lights. And here I hit Compile and Save. Well, I'll close the Blueprint Actor window. As you see, we have access to all of these in the Details section. That is, if I make copies of these, I can very easily, for example, select this front light of mine for this lamp and turn it off completely. Just that simple. I'll select it and set the intensity back to 8. Or we can click the Reset to Default option here. Now, how can we place the blueprint we have, this blueprint actor we have, onto these columns we had here? Since we've already done an arrangement, it's not logical to have to do all of them from scratch again. So what do? First of all, I'll delete my actor. I'll select the columns that are meant to take this lighting model in the scene. Now I have to say, look, Earnly Engine, my lovely software, I have something called Column Actor. You take this and put it in place of the ones I've selected. How does it do this? It says, go to your content browser, select what you want in the blueprint section, then come back to your viewport. Now right-click on one of these models, click the Replace button, and I'll bring up what you've selected over there. Just a click is enough. It places it very quickly, and done. Just that simply, I was able to substitute these lights. Now I select all my lamps, I go into the blueprint, select BP Light, right-click, and replace. Now I'll repeat this here as well. Just that simply. Well, I've placed these, and now as the number of my lights increases, I feel their intensity isn't quite right. If I had a setting like exposure that I could apply to my entire scene, I could control the light intensity and the final image quality much more easily. For this purpose, we have something in Unreal Engine called a post-process volume. Well, you can very easily open the Create menu, write Post in the search section, and have it bring up post-process for you, or in another way, you can add a post-process volume to your scene from the Visual Effects menu. Look, I've added the post-process volume here, but it didn't have any effect on my scene. To see its effect in my scene, I have to do something. Select it, go to the Details section, type Unbound in the search here, and check the Infinite Extent Unbound box. Now all the post-process changes will be applied to the entire scene for me. What does this post-process do? It acts for us exactly like Photoshop. Look, we take an image into Photoshop and start using various features we have, like exposure, highlights, or shadows. We start changing our final image. We increase or decrease its exposure. We can control the amount of bloom and add to it and things like that. Whatever we do in post-process or post-production, we can implement it here in this volume. Let's implement the simplest required setting here in the scene within the post-process volume, that is, controlling the exposure. First of all, I'll click the Collapse All Categories option here. So everything is closed and we don't have a very messy menu here. I go to the Lens section. Most of our work is exactly in this Lens menu. The first option I want to change is the Exposure option. We check the first two boxes for exposure and don't touch the settings. Let's leave them for now. I come here and turn on the Min EV 100 and Max EV 100 options and set them to 0. Well, when I set them to 0, what happened was as if all my lights, that range and that extraordinary intensity and brightness they had, were controlled and decreased. So generally, we can control the amount and intensity of our lighting in the scene with exposure. Now this value is 1. If I set it to 5, the intensity increases. If we set it to 0, the intensity decreases, and the further it goes towards negative numbers, the lower the intensity of these lights becomes. Their influence intensity in our scene actually becomes less. Now, if we want a light to stand out more in this exposure, we have to go select it and increase its intensity very much more so we can see its effect in the scene. Now, what value should we set it to? Here, we don't want to talk about the post-process subject at all. We want to see how to use post-process for our own lighting. To avoid getting involved with too many things, I'll give you a series of ready-made settings. I'll say adjust them like this. If you have information about the post-process and generally how it works in Unreal, then adjust it yourself. If you don't, before you start your lighting, enter these numbers I tell you into the post-process and then start your lighting. First of all, we set the exposure to 1 in the auto exposure mode and set the min and max to 0. Well, that's for the exposure subject. We go to the bloom section and turn on the first two items, namely method and intensity. We set the method to convolution and then set the intensity here to, for example, 2. What happens is it gives me a bloom. Now if I increase its value, we can better see here that, well, this bloom it's giving me here becomes exactly what I need to have in my final image. Depending on your needs, you can increase or decrease its intensity. Well, I'll leave it at 5 for now. The next change I'll make is in the Chromatic Aberration section. Here, I'll turn on the intensity. And to see its effect, I'll set the value to 1. See what happens when you turn on this parameter. You see it separates the R, G, and B layers on the edges of the work. It's an effect that happens in real cameras, and we usually add it to make our image more natural. but not with this intensity. A value like 0.2 to say 0.6 or 0.7 can be a suitable value. You can adjust this number according to your own taste. The next thing we want to adjust is in image effects, where I can increase the exposure a bit. For now, let's set it to 0. In image effects, you can define a vignette, which, as you see, darkens the edges of your image. Don't overdo it, in my opinion. In this effect, between 0.4 and 0.6 is a suitable and effective value. The lower it is, the better. The next option is sharpen. If you bring sharpen up, for example, set it to 2, the image it gives you is much sharper than normal. See, it's much sharper. But there's a very important point. The higher the sharpen value, the more noise in your image increases. So preferably adjust its value between 0.2 and 0.8, depending on the effect you want to have in the image. And all you need to change in the post process are all the items I told you. For now, for the camp project, these items suffice. Let's go to the next video and talk about the final lighting I want to do on the file. Yeah.